Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on rectification and capacitance from May-June 2022, paper 4, variant 1. In this question, we will discuss these two main topics, rectification and capacitance, in depth by solving past paper question. This question will help you to understand rectification and capacitance in depth. Let's study together. Let's improve together. For our question number 5, it is given to us figure 5.1 shows 4 diodes and a load resistor of resistance 1.2 kilo ohms connected in a circuit that is used to produce rectification of an alternating voltage. For part A1, we need to state what is meant by rectification. Rectification simply is a process. With the help of this process, we can convert AC into DC. So simply we can say converting AC into DC is called rectification. So we can say converting AC into DC is called rectification. Converting AC into DC. So this is how you can simply state what is meant by rectification. And this question has 1 mark, that is B mark. If you simply write down converting AC into DC is called rectification, you will get 1 mark. For the second part, we need to state type of rectification produced by the circuit in figure 5.1. If you look at this figure, you can see we have 4 diodes. If we have 4 diodes, this is called full wave rectifier. So we call this one full wave rectifier. Full wave rectifier. Now let's try to understand about types of rectifications and then we will answer this question. There are 2 types of rectifications. We can simply write on here. Types of rectification. The rectification has 2 types. One we call is half wave rectification. Half wave rectification. And the second one is full wave rectification. Full wave rectification. Half wave rectification we can achieve by just using 1 diode. So we can achieve this one by just using 1 diode in a circuit. 1 diode. And this half wave rectification, the curve of this one, if we draw voltage against time, means time on x-axis, we will get curve, means we will get this half cycle, there will be voltage across load resistor, and half of the cycle there will be no voltage across load resistor. So this is shape of half wave rectification. On other hand, full wave rectification we can achieve by using 2 diodes in a circuit. By using 2 diodes, or we can achieve this one by using 4 diodes. 2 or 4 diodes. We can achieve full wave rectification. And if we look at voltage against time graph for full wave rectification, so here we have voltage and here we have time. So the voltage across the load resistor, we will see like this, means we have voltage that is changing with time, and then we have voltage that is again changing with time, and so on. Let's try to compare these 2 types of rectification. In case of half wave rectification, you can see half of the cycle there is no voltage across load resistor. But in case of full wave rectification, there is always voltage across load resistor, that voltage is changing with time. Now if you look at similarities between half wave and full wave, you can see in case of half wave voltage is always positive, and in case of full wave voltage is also always positive. It simply means that current will enter load resistor always from one side. Now simply you can say direction of current in load resistor will not change with time. In this case we have 4 diodes. It simply means that this one is full wave rectification. So this one is full wave rectification. This question has only 1 mark. If you have written full wave rectification, you will get 1 mark, and that is B mark. For part B, it is given to us a sinusoidal alternating voltage Vin is applied across the input terminals X and Y. The variation with time t of Vin is given by the equation. Vin is equal to 6.0 sine of 25 pi t. Vin is in volts and time is in seconds. For part B1 on figure 5.1, we need to label the output terminals P and Q with the appropriate symbols to indicate the polarity of the output voltage. Now let's try to understand first of all how we can indicate the polarity. Let's try to understand this one with one very simple example. Imagine that we have a battery and this battery has a resistor that is connected across this battery. So this one is the resistor. So this terminal of the battery is positive and this one is negative. So conventional current will flow from positive terminal of the battery and it will pass through this resistor. Now we need to understand this side, and this side is current entering side. Current entering. So we have current entering side, and current entering side is connected with positive terminal of the battery. So we will mark this side positive, and current leaving side we can write on here, current leaving side. Current leaving side, and that one is connected with negative terminal of the battery, and we will use this understanding to mark the polarity of this resistor, means the polarity of the output. So in this case, when this terminal is positive, you will see current will flow like this, and when current will reach at this point, current cannot go this way because this is connected in reverse biased. So this one is connected in reverse biased, so current cannot flow this way. So current will flow like this. After reaching at this point, current cannot pass through this diode because this is connected in reverse biased. So we can say this one is connected in reverse bias. So current simply will flow like this. Current will go this way and current will enter this resistor from Q. So this side has to be positive, and current will pass through this resistor and come back like this. So it cannot go this way because this potential, we can say, let's say this potential is V1 and potential at this point is V2. So in this case, V1 is greater than V2. So current only flow from high to low. So current will not flow this way. So current will go through this diode and come back to this power supply. So this is how current flows. Let me also use line here, solid line here, so you can see what is happening in this case. Now let's try to understand this one using a different color. So I will be using red color now. Now imagine that when this side is positive, so in this case current will flow like this. I will be using arrows here. Current will flow like this, current will go here. When current will reach this terminal, current has two ways to go. It can go this way or current can go this way. In this case, current will go this way because this is connected in reverse biased. So current cannot flow through this diode. So current will go this way and current will flow like this. And finally, current will enter from this side and pass through this resistor, and then current will reach at this junction. Now we need to understand which way current will flow. You need to understand, if again I say this is V2 and this one is connected with positive terminal of the power supply, let's say this one is V1. In this case, V1 again is greater than V2. So current cannot pass through this one because current cannot flow from low to high potential. So current will flow this way, and this is how current will flow. Current cannot flow through this diode as well because this side of the diode is at higher potential. Simply we can say this is at higher potential and this one is at lower potential. So current cannot pass through this diode. So that's the reason current will go this way, means current will go towards negative terminal. So when this is positive, this is negative, and when this was positive, this was negative. Now we are talking about when this side is positive, so this side is negative. So this is how current will flow. For the sake of this question, simply you need to mark this side is positive and this side is negative. So this is how you can mark. Now let me explain you this one using a different method, or simply you can say shortcut. So first of all, I will clean this one and then I will explain you one shortcut. If you look at these diodes, look at this junction and also look at this junction. At this junction, you can see these diodes, they converge. So they converge. If we compare here, so they converge at this point. So we can say they converge at this point, and this side has to be connected with positive. So this is positive terminal of the output, and this side where the diverge, you can see at, let me mark this point. Let's say this is point 1, and let's say this is the second point. At this point, you can see at the second point, you see they diverge, mean they go away from each other. They diverge like this, go away. And that side where they diverge, that one has to be connected with negative. So this one is negative terminal of output. And the side where they converge, that one has to be connected with positive. So this is how you can figure out what is positive terminal of output voltage and which one is negative. So this one has to be positive because this is connected with this point where diodes converge, and the other is diverge, where diodes diverge. So this is how you can find out. For part 2, it is given to us the magnitude of the output voltage Vout varies with time t as shown in figure 5.2. On figure 5.2, we need to label both of the axes with the correct scales. Use the space below for any working that you need. For this question, it is given to us V in is equal to 6.0 sine of 25 pi t. Now, if we compare this one with general equation, we can simply write down V as a function of t. This is equal to V peak, or simply you can say this is V naught sine of omega t. So this is sine of omega t. Now from here we can find out the peak value of the voltage. Peak value of the voltage is, simply we can say V peak is equal to V naught, and V naught is equal to 6.0 volts. Omega in this case has to be equal to 25 pi. So we can say omega is equal to 25 pi. We need to find out time period. So omega is equal to 2 pi over time period. From here we can say time period will be equal to 2 pi over omega, and value of omega is equal to 25 pi. So this is equal to 25 pi. Pi we can cancel with pi, and we left with t is equal to 2 divided by 25. Now if we solve this one, value of time period we will get that is equal to 0.08 seconds. So this is value of time period. In this case, one time period is this. So we can label this one, this is 0.08, and this one will be 0.06, and this one will be 0.04, and here we can label 0.02. Now the peak value of the voltage is given. So peak value of the voltage is 6.0, and this is halfway. So this one we can say will be 4, and this one we can say will be 8.0. So this is 4.0. So this one we can label is 0. So this is how you can label axis. Let's try to understand a little bit more about time period. How do we know that we need to label time period at this point? The reason is that over alternating input voltage, this is the time period of alternating input voltage, and over alternating input voltage has time period that is equal to 0.08 seconds. So this is over alternating input voltage. So that's the reason we have labeled time period here, not here. For part C, it is given to us the output voltage in B is smoothed by adding a capacitor to the circuit in figure 5.1. The difference between the maximum and minimum values of the smoothed output voltage is 10% of the peak voltage. On figure 5.1, we need to draw the circuit symbol for a capacitor, showing the capacitor correctly connected into the circuit. You need to understand, for smoothing, when we connect capacitor has to be connected across load resistor, means in parallel. So here we need to connect over capacitor. This is how capacitor has to be connected. For this question, simply you need to draw the symbol for capacitor, and this one has to be connected across load resistor. This question has only 1 mark. If you have drawn this symbol, you will get 1 mark. For the second part on figure 5.2, we need to sketch the variation with time t of the smoothed output voltage. But for this question, it is given to us the difference between the maximum and minimum values of the smoothed output voltage is 10% of the peak voltage. Peak voltage, we have already discussed that peak voltage is equal to 6.0 volts. We can simply say in this case V max is equal to 6.0 volts. So the V minimum, that has to be equal to 90% of the peak voltage, 90% of V max. Or simply we can say 0.90 multiplied by 6.0, and this one will be equal to 5.4 voltage. So this is the minimum value of the voltage across load resistor, and this one is the maximum value. In order to sketch the curve, first of all we need to label Vmax and also we need to label Vmin, and then we can sketch the curve. First of all, we need to understand Vmax is the peak value of the voltage and Vmax is equal to 6.0. Now we need to understand the difference between these two, mean difference between 4 and 6. Difference is equal to 2 volts. We can simply write down 2 volts. And 2 volts is divided into 5 parts. We can divide this one by 5, means by 5 boxes. So in this case, we will get 0.4 volts per small box, So it simply means that this is 4. So here we will have 4.4, we will have 4.8, and here we will have 5.2, and here we will have 5.6. So the 5.4 is between 5.6 and 5.2. Simply we can draw a line. So we can simply draw the line. So the line we need to draw between 5.2 and 5.6. So this is how we can draw the line. So our minimum voltage should not be lower than this one. Maximum voltage across the load resistor is 6 and minimum voltage across load resistor is 5.4. Now simply we need to connect these 2 points using a curve. So this is how you can connect using a curve. So between these 2 points, capacitor will discharge. So we can say capacitor will discharge between these 2 points. And then again capacitor will charge, means the battery voltage will increase across capacitor and capacitor will start charging. So in this region, capacitor will charge because the voltage across capacitor will increase. So capacitor will start charging. And again capacitor will discharge because the battery voltage across the capacitor will start decreasing. So capacitor will discharge. So this is how you can sketch. Again here capacitor will start charging. So between these 2 points capacitor will charge. So we can simply say capacitor will charge. And here capacitor will again discharge. So we can draw the line. Capacitor will discharge. And here you can also draw capacitor will discharge. So we can start from here. Capacitor will discharge and capacitor will charge again. So this is how you need to sketch the curve. If you draw simply a straight line between these 2 points, that is also acceptable, but the better way is to draw a curve because capacitor is discharging, and discharging of capacitor is not a straight line. If we have voltage and we have T on x-axis, so the capacitor will discharge and capacitor will follow this curve. In this case, V as a function of time is equal to V naught e to the power of minus t over RC. So this has to be exponential decay curve. So it's better to draw the curve, not a straight line. For the last part, we need to calculate capacitance of capacitor. In order to calculate capacitance of capacitor, we need to understand discharging of capacitor. And discharging of capacitor is part of new syllabus. Let's try to understand first of all about discharging of capacitor. So simply we can say discharging. When a capacitor is discharging and you need to find out value of potential difference across capacitor at any given time t, you can simply use this equation. You can write on V as a function of time is equal to V naught e to the power of minus t over RC. Let's say we need to find out value of V after time t, then simply you can write down v naught. The time taken for v naught to become vt, that time is t, and that time is here. So this is the time taken, and this is the value of v after time t. In this case, we have peak value, that is 6.0, and after time t we have value of v, that is equal to 5.4. So simply we can write down here we have 5.4 after certain period of time, and the peak value we have, that is 6.0 times e to the power of minus t over rc. So we can simplify this. We can write down this is 5.4 divided by 6.0 times e to the power of minus t. We don't have value of t, and this one has to be divided by rc. Value of r is given, that is equal to 1.2. This is the resistance of the circuit, 1.2 times 10 to 3 ohms, and this is multiplied by c. Now we need to find out value of t, and value of t is the time taken for this capacitor to discharge from 6.0 to 5.4, and that time you can find from here. So the time taken in this case is 0.054 minus 0.02, and this time taken we can write down here. We can say t is equal to 0.054 minus 0.02, and this one is equal to 0.034. So this is the time taken for the voltage to drop from 6 to 5.4, from 6 to 5.4. So this is the discharging time. So simply we can write down here this is 0.034. So we can clear this box and we can write down the value here, and this is 0.034. Now if we take ln on both sides, we can say ln of 5.4 divided by 6.0. This one will be equal to minus 0.034 divided by 1.2 times 10 to 3 times c. Ln of e is equal to 1, so that's the reason we have cancelled e, because ln of e is equal to 1. So ln of e is equal to 1. Now we need to find out value of c, so we can simply write down c will be equal to minus 0.034 divided by 1.2 times 10 to 3 times ln. I'm just writing this value, but you can use calculator. You can find out ln of 5.4 divided by 6.0. So here you need to write down ln of 5.4 divided by 6.0. And if you solve this one, your final answer has to be equal to 2.7 times 10 to 4 farads. And this is the final answer. Our answer has 2 SF because in the raw data we have 2 SF. This one has 2 SF, this one has 2 SF, and here we have 2 SF. Means the minimum value in given data is 2 SF. So our final answer also has to be up to 2 SF. So our final answer is 2.7 times 10 to negative 4 farads. And this is the final answer. This question has 3 marks. The first mark you will get if you have got the right value of discharging time, or if you have got right value of minimum voltage across capacitor. And the second mark you will get if you have used this formula and you have plug-in values. So this one is the first C mark and this one is the second C mark. And the last mark is answer mark. If you have got the right answer, you will get this mark. This is how marks will be awarded for this question. That's all for this video and also for this question. I'll see you in next video, and the next video will be coming very soon. I will be explaining remaining questions in this paper.